Today we'll continue with solving some problems on what we did on Friday, and then also learn how to verify if events are independent or disjoint. Also learn how to draw the tree diagram. And so before we proceed, I decided to provide this information here, which I believe you already know. So whenever we have the standard deck of playing cards, the total number of cards are 52. And then hearts, which is red, is 13. Diamond, which is also red, is also 13. And then clubs and spades, which are both black, they are also 13 each. And then each of them also has an ace. And then when we talk about face cards are the jack, the queen, and then the king. So each of them has three of them. So each has jack, queen, and then the king. So it's very important that you know this. Now let's try to solve one of your homework problems. So it says that a card is drawn at random from a standard deck of 52 cards. Now we want to find the following conditional probability. The probability that a card is club given that it is black. So to be able to do that, we say, okay, then let C be the event that the card drawn is a club, and then let B be the event that the card drawn is black. So we've been able to define that. And then the question is in the probability that the card is a club given. So we know, so that is going to give us, we are looking for the probability that what? Given that it is black, and then we are looking for the probability that the card is what? Club. So it's very important that you know how to be able to write the question in the conditional probability form. So this is how to write that. So when we write this on Friday, we wrote the formula for this, which is giving us this. So it means that the probability that the card is club, given that it is black, is equal to probability that is club and black, given that it is what? Divided by probability that is black. Okay, so now let's try to do each of them separately. So now we want to find the probability that the card is club and then black. So when we come here, we can see for it to be club and black, this is club, it's also black. That is what? 13 cards. Can you see that? We are looking for the probability that it is club and then black. Is that okay? So then that is what? 13 cards. So there's going to be what? 13 over 52. So that is what is here. Now we have been able to do for the numerator. The denominator says the probability that it is black. So for it to be black, now how many black cards do we have? We have 26 of them. 13 is club, another 13 is also what? Spade. Is that okay? They are all black. So then the total number of blacks here is going to be what? 26. Does that make sense? And so probability that it is black is what? 26 divided by what? 52, which gives you 1 over 2. So now to compute the conditional probability, the first one we had 1 over 4, which is the same as what? 0.25 divided by probability of black, which is what? 0.5. And when we do this, we get 0.5 as our final answer. Any question? Okay. So I want you to try this one. Don't focus on the solution. Try to do this by yourself. B says that the probability that a card is black, given that it is clap. So you have to start by defining the event. So we say let C be the event that the card drawn is what? Clap. Let B be the event that the card drawn is also what? Black. So we are looking at what? Probability that the card drawn is black, given it is clap. So given it is clap. Do we see that? It's very important. If you make a mistake with this, then the rest would be incorrect. Does that make sense? Mhm.
The formula for is that the probability formula? Like what's the name for that formula?
The name for the formula is conditional probability.
Conditional probability.
Yeah, you can find it. Yeah. Okay.
That's the one where you're like looking for the probability of something on the condition that it is something.
It has something happen. Yeah. So when you do this, you just have to be able to look at your sheet and write the formula down, which is this one here. So now we just have to be able to find probability that it is clap and black, and then probability that it is what? Clap. So let's come here. It is clap and black. Clap and black. That is what? 13 over 52. Is that okay? So that is going to give us what? 13 over 52. And then probability that it is clap. For probability that it is clap, how many claps do we have? We have only 13 of them. Is that okay? So that is also 13 over 52. So when you do that, both of them, you are getting 1/4. And then we apply the formula. So that gives us 1. And then let's get to C. The probability that a card is a 2, given that it is black. So you define, I said let T be the event that the card drawn is a 2, and let B be the event that the card drawn is black. So we are looking for probability that the card drawn is a 2, given that it is black. So does that make sense? You see, given that it is black. When you look at this one here too, given that it is clap, you see. When you look at this one too, given that it is black. So whenever you write this, the formula is probability of T given black is equal to probability of T 2 and then black divided by probability of what? Black. So when you come here, probability that you draw a 2 and it is black. Now, you can draw a 2 in claps and you can also draw a 2 in spades. Do we all agree? They are both black. Does that make sense? We are looking for ability of you drawing a 2 and it is black. Is that okay? You can also draw a 2 in hearts and diamonds, but we are not focusing on those ones because it is red. Is that okay? We are looking for the probability of you drawing a 2 and black. Is that okay? So that is why we are focusing on these guys here. So for you to draw a 2 and black, you can draw one in clap. You can also draw one in spade. Is that okay? That is going to be what? 2. Is that okay? And then, so that is going to be what? 2 out of what? 52. Is that okay? Which gives you 1 over 26. And the probability that it is black, what are the total number of black cards here? It's 26. 13 are clubs, 13 are spades. Is that okay? So that gives you 26 over what? 52. So 26 over 52 gives you 1 over 2. And then when you do this, you just plug them into the formula. Use your calculator, you get 1 over what? 13. Let us try the last one. The probability that a card drawn is queen, given that it is a face card. So I decide to define the variable. So I say let Q be the event that the card drawn is a queen, and let F be the event that the card drawn is a face card. You have to understand what a face card is. A face card is either a jack, a queen, or a king. Those are the face cards. Is that okay? Good. And so probability that what a card drawn is a queen, given that it is a face card, I used F to be or to become my face card. That is what I define here. And so this gives you this. So whenever you're able to get this thing here rightly, you just have to be able to write the formula here. So now let's try to solve them one after the other. We are looking for the probability that it is a queen and a face card. So we are looking for a probability that is going to be what? A queen and also what? Face card. So here, a queen and a face card. We are not, so a queen and a face card, it means that you can draw a queen in hearts. You can also draw a queen in diamonds. You can draw a queen in clubs and also a queen in spades. Does that make sense? So that's going to give you what? That means how many queens can you draw? You can draw 4. Is that okay? Because 1 is in red, you could draw 1 and it's going to be a queen, but it's going to be hearts. You could also draw 1, it's going to be, it could be diamond, it could be clubs, it could be spades. So that is going to give you what? 4 over what? 52, which is here. Now, divided the probability that is going to be a what? A face card. So we have to be able to know what the face card means. Like I did to tell you, face card is what? So I see I decided to write it here for you. Face card is jack, queen, and then king. You'd have all those 3 in hearts. You'd have all those 3 in diamonds. You'd have all those 3 in clubs. You'd have all those 3 in spades. So it's going to be what? 12 of them. Is that okay? So that's going to give you what? 12 over 52. So you see, that's what I wrote here. 12 over 52. And so then now when you implement that, 1 over 13 divided by 3 over 13, you get 1 over 3. Any questions so far? Okay. Now, I also recommend that you write this in your sheet. So we've already talked about independent events. In your homework, in your test and your quizzes, we would want to test you for you to be able to tell if events are independent. So anytime you're asked to determine if 2 events are independent, all you need to verify is this. 2 events are independent if the probability of B given A is equal to what probability of B. Is that okay? This is the same thing as probability of A given B is equal to probability of A. So if this assumption holds, then it means that those 2 events are independent. So anytime you're asked to check if 2 events are independent, write this down and then try to what? Verify if this is the same as this. If they are the same, it means those 2 events are independent. Does that make sense? Let us look at how to implement that. So here, to be able to check if 2 events are independent, I want to use this example here to explain how to implement that. So we are told that the survey told that 33% of college students are in a relationship. So we know P of R equals 33%, 0.33. And then 25% are involved in sports. P of S equals 0.25. And then 11% are involved in both. So P, R, and S equals 0.11. Now, we want to verify, is you being in a relationship and being involved in sports independent? So we are trying to verify if these two events are independent. So to be able to verify that, we are going to rely on this guide here that I recommended that you write them in your sheet. So first and foremost, we are interested in verifying if being in a relationship and sports are independent. So first and foremost, let's try to write the formula down. So P of R given S should be equal to probability of R. If this assumption holds, then they are independent. Is that okay? If you also decide to do P of S given R should be equal to P of S, should also be the same thing. Is that okay?
You have to do both to prove they're independent.
So you'd have to, yes, you have to do both to prove they're independent. But the point is that, for example, with this, we have P of R already. Is that okay? So it means you have to do this one and compare the answer to P of R. Does that make sense? Okay. That's a good question. So let's try to do P of R condition S. We know this is the same thing as P of what? R and S divided by P of S. P of R and S is 0.11 divided by P of S is 0.25. So when you do that, you get 0.44. Is that okay? So this, it means that P of what R condition S is 0.44. Let's compare that answer to P of R. P of R is 0.33. Are they the same? No. Is that okay? So since they are not the same, it means that what the events are not independent. Does that make sense? Okay. Then the other thing I also recommend you write down is that what we've already talked about them, disjoint events. Disjoint events means that what they have no outcome in common. It means that their intersection is zero. Does that make sense? So just know that disjoint events means that they have no outcome in common. Mutually exclusive events also mean that what they have no outcomes in common. Does that make sense? Okay. So now let's look at another example. So here, researchers report that 71% of online adults use Facebook. So 71% of online adults use Facebook, 18% use Twitter, and then 15% use both. So based on this information, I know that P of F is equal to 0.71. I also know that P of T is equal to 0.18. And then P of T and F is equal to 0.15. Does that make sense? So F is for Facebook and then T is for Twitter. Now, the question is that we are trying to verify if using Facebook and Twitter are mutually exclusive. What does mutually exclusive means? Mutually exclusive means that what? They shouldn't have any outcomes in common or their intersection should be zero. Does that make sense? That is what mutually exclusive event means. Here, their intersection is what? 0.15. It is not zero. Is that okay? And so we can say that what? They are not mutually exclusive. Or they are not what? Disjoint event.
So are not mutually exclusive and disjoint the same thing?
Yes.
And then something can be independent but not disjoint?
Mm-hmm.
Okay.
Yeah. And then let's get to 2. We are trying to verify if Facebooking and tweeting are independent. So remember I told you to be able to write this down. So to be able to verify that, so we want to verify if Facebooking and tweeting are independent. So we try to what? So I try to do probability of tweeting given Facebook should be equal to probability of what? Don't go and mix them. Don't put F here and T and come and put here to be T. Is that okay? If you, for example, if you write this way, this is incorrect. Is that okay? That is not what I wrote. You see, when here is B, given A, here is B. Do you get what I mean? So that is the rule. So you have to stick to the rule. And you don't have to worry because you have the option to be able to what? Use sheets in the exam and your test. So just write the right way and implement them the right way. So we are interested in so if we want to verify independence, we want to what, verify that this is equal to this. Luckily for us, we know that P of T is 18. So let us verify this one. So we know this formula is given as this one here. So probability of T given F is probability of T and F divided probability of what? F. Probability of T and F is 0.15, which is here. Probability of F is 0.71. And when you do this, you are going to get 0.21. 0.21 is not the same as 0.18. Can you see that? 0.21 is not the same as 0.18. And so they are not what? Independent. If we had 0.18 here, it means that what? They are independent. Is that okay? So know how to verify if events are mutually exclusive, disjoint, and independent. Okay, now let's learn how to construct tree diagrams. So tree diagrams help us to be able to handle conditional probabilities more easily. And so tree diagrams, we are going to construct, we are going to learn how to like use pictures. So for example, let's do an easy one. Suppose we toss a coin. Suppose you toss 2 fair coins. We want to construct a tree diagram to represent all the possible outcomes. So the first one gives us, so this way. When you toss a coin, you either get what? Head or tail, isn't it? What's the probability of getting head? What's the probability of getting tail? Is that okay? So when you get head and you toss again, you can also still get head and tail. When you also get a tail and you toss again, you can also get head, tail. Does that make sense? So this is how to construct tree diagrams. And you can do that for if you toss a coin 3 times, if you toss a coin 3 times, and then you can go on and on and on and on. Is that okay? So if you want to get head and head, you multiply this and then this. So this is head and head. Is that okay? First one head, second one tail, and so on and so forth. Okay. So based on that, I want you to read this problem and then try to draw the tree diagram for this situation. I picked this example from your homework problems. So try to construct a tree diagram for this situation. So let's do it together. We are told that a website reports that 90% of its users are from a certain country. Is that okay? You can see from here. So let me put here maybe certain country. And then here would be, let's say, can we see that? So I put here, let me try to write it more clearly. How did I do this? I'm told that 90% of its users are from a certain country. Okay. I don't know what that country is, so I decided to put here certain country. Or you could also put country, and here will be not certain country. So does that make sense? And here is going to be what? 0.9. Here would be what? 0.1. Does that make sense? Any question on this one? So I got that information from this one. Good. Then it goes ahead to say, of users from the country, 1/2 log on every day. Of users from the country, 1/2 log on every day. So of users from this certain country, so it means I'm going to have, so here is going to be log on every day. Is that okay? And here will be not every day. And I'm told that what? 1/2. So every day is going to be 0.5. Not every day will also be what? 0.5. Does that make sense? Do you see why I put it? I put it from what? The certain country, because I'm told that of users from the country, Is that okay? 1/2 log on every day. So log on every day, not every day. So 0.5 and 0.5. And says that of users from other countries, which is here, 2/3 log on every day. So here is also every day. So here is what? 2/3. And then here will be what? Not every day. Here, if here is 2/3, what will be here? 1/3. Does that make sense? So this is how to construct the tree diagram. I will go over again. To construct the tree diagram, we try to what? Read the problem. Is that okay? And then we'll use the information on the problem from the problem to construct our tree diagram. A website reports that what 90% of its users are from a certain country. So I just do this. And then I could put country here. And then here will be not country. And I'm told country is what 90%. And so if country is 90%, here will be what? 0.1. Does that make sense? Good. And then, so I've been able to fix this one here. Then we go ahead. It says that of users from the country, so of users from this country, 1/2, that is 1/2 log on every day. So of this country, I create another branch. So I'll put every day here. Here is 0.5. Is that okay? And then here will be what? Not every day. Here would also be 0.5. Then it goes ahead. Of users from other countries, 2/3 log on every day. So here is going to be what? Every day. 2/3. Not every day. 1/3. Does that make sense? So this is how to construct the tree diagram. So we've been able to answer the first one. This is an example in your homework. So you need to know how to do the tree diagram. And then the other question is that why is a tree diagram better in this case? So a tree diagram is better because the conditional and the marginal probabilities are given. So like I did tell you that tree diagrams are better, or the pictures are more helpful when we have conditional probabilities. So you see. And then the last one says that where are the joint probabilities found? So the joint probabilities are, for example, what does it mean? It means that if you want to find country and every day, you just multiply 0.9 by 0.5. So the joint probabilities are found at the end of the branches. So here. So for example, if I want to fill in the branches, I'm going to get what is 0.9 times 0.5? Yep. So 0.45. So that is a joint probability. So country and not every day. So another 0.9 times 0.5, which is also 0.45. And then 0.1 times 2/3. That is 0.067. And then 1/3 times 0.1, 0.033. So these are the joint probabilities. So the joint probabilities are found at the end of the branches. Is that okay? Any questions so far?